Now we are seeing centroid and moment of inertia procedure for L section. Let us see this problem. Find the centroid and moment of inertia of L section about xx and yy centroidal axis as shown in the figure. So here we have to find out the centroid of for this L section, and also we have to find out moment of inertia of this L section about xx and yy centroidal axis. So if you see, first of all, the given L section is a composite or complex shape. So to find out centroid for this composite shapes, we have the formula a1 x1 a2 x3 x by a1 plus a2 plus a3. So here we can divide this given L section into two simple areas, that is two simple rectangles. So we'll write the x bar formula as a1 x1 plus a2 x2 by a1 plus a2. So here a1 a2 are the areas of first figure and second figure. So for that we have to divide this L section into two parts. So if you see here, we can divide this L section like this. Suppose if you divide this L section here at this place exactly, so that will be divided into two parts, that is 60 by 20 one part, and this second part will be 20 by 60. Here if you take here, suppose if you see this diagram, we have divided, so like this. So this part will become 60 by 20 and the above part will become 20 by 60, like that. So the area of part 1 become 60 into 20, that is 1200, and area of part 2 will become 20 into 60, 1200 mm square both. And here let us understand what is x1, x2 and y1, y2 here. So x1 is the distance of centroid or center of first figure from the y-axis. So what is y-axis means, here we have to keep this given L section in the quadrant, or we have to draw x and y-axis to locate the centroid of the total figure. So in that process, just take x and y-axis such that you should get all x1, x2, y1, y2, and also the coordinates of centroid as positive. So to get all the values as positive, so draw x-axis from the bottommost figure and draw y-axis from the leftmost part of the figure. So that is the technique to be followed to draw x and y-axis here. So we are keeping this in a coordinate system or first quadrant, or we are drawing x and y-axis. So the x1 is, or the meaning of x1 is the distance of centroid or center of the first figure. So we have divided first and second figure. So distance of centroid of the first figure from the y-axis. So if you see, if you draw y-axis here, x-axis here, so this x1 will become 30 mm. Why? Because total is 60. So this x1 is 30, center of the first figure, and also x2, center of the second figure. Total is 20 given. So x2 is the distance of centroid or center of the second figure from this y-axis. So this is total is 20 and this half is 10. So x1 is 30 mm and x2 is 10 mm. So in the same way, what is y1 means? Distance of centroid or center of the first figure from the x-axis. So that will become 10. Why? Because this total is 20 given in the question. So half is 10 mm. And also y2, distance of centroid of or center of second figure from the x-axis. So that is, so total is 80, and if you divide here, so this is 60. 60 half is 30 here. So from here to here it's 30 and plus 20. So 30 plus 20, 50. So the y2 value will be 50 here. So, and if you substitute and if you simplify that in the x bar formula, that is a1 x1 plus a2 x2 by a1 plus a2. So a1 we got 1200 into x1 we got 30 plus a2 1200, x2 we have seen it is 10 by a1 plus a2, 1200 plus 1200, and if you simplify that, we are getting x bar value as 20 mm. And same way y bar formula a1 y1 plus a2 y2 by a1 plus a2. So a1 is 1200 into y1 we have seen it is 10 plus a2 1200 into y2 we have seen it is 50 by 1200 plus 1200. So y bar, if you simplify that, we are getting y bar 30 mm. So x bar we got 20 mm and y bar 30 mm. And if you want to look at that, so you can look at here, that is like so this is a x bar, that is distance is 20 mm, that is x bar is from this y axis, its distance is 20 mm, and y bar if you represent, that is 30 mm. So this is 20 and this is 30. So this is the y bar location. So this is the location of the centroid. So x bar is 20 mm and y bar is 30 mm. So we have completed centroid procedure, and let us see, or let us find out moment of inertia of this L section about its xx and yy centroidal axis. So to find out that, we'll use the parallel axis theorem formula. So we know from the parallel axis theorem, or suppose if you have a area and if you want to find out moment of inertia of this area about any axis other than its own centroidal axis, suppose it is AB, so we can write formula IAB is equals to IG, nothing but moment of inertia of its this area about its own centroidal axis, plus A, that is area, into h square. H is the distance between the centroid to the axis about which we are finding out the moment of inertia. So if you apply to the xx, suppose if you take this as xx, so it is ig plus a, this will become, so if it is x direction, this will become y, so hy square. So the same way if you do about yy, so this ig plus this will become x direction. If this is yy, this will become x direction. So ig plus a hx square. So by using this concept, that is the parallel axis theorem concept, we'll find out the moment of inertia of these individual parts we have divided already 1 and 2. About, suppose we'll find out moment of inertia of this part 1 about this xx, and also we'll find out moment of inertia of this second part about this xx, and we'll add to get total ixx of the figure. And the same way we'll find out moment of inertia of this part 1 about this yy, and moment of inertia of this part 2 about this yy, and we'll add those two to get total Iyy of the figure. So let us see step by step here. So first of all, to get moment of inertia about xx central axis, so Ixx, so we have divided into two parts here. So we can write Ixx1 plus Ixx2, and Ixx1 is nothing but Ig1 plus A1 Hy1 square. So let us see what is here Hy1 and Hy2, Hx1 and Hx2. Let us see first of all what is Hy1 here. So the meaning of Hy1 is the, or the H1y1 is nothing but distance between the centroid of the first figure to the centroid of the total figure. So here is the location of the centroid of the total figure. So Hy1 is the distance between the centroid of the first figure to the centroid of the total figure along y direction. So this is nothing but Hy1. So from this figure, if you want to write Hy1, so it is y bar minus y1. So Hy1 is nothing but y bar minus y1. So y bar we got 30 minus y1 we got 10. So 30 minus 10, so 20 mm. So Hy1 value is 20 mm. So in the same way, let us see what is Hy2. So Hy2 is nothing but distance between the centroid of the second figure to the centroid of total figure in the y direction. So we can write from this figure Hy2 is nothing but y2 minus y bar. So that is nothing but Hy2. So Hy2 is y2 minus y bar. So y2 we got 50 mm and y bar 30 mm. So 50 minus 30, 20 mm. So Hy2 is 20 mm. And here let us write these Hy1 and Hy2 values in these formulas. So here we are seeing this one, and so Ixx1 is equals to Ig1 plus A1 Hy1 square. So Ig1 is, suppose if you divide here, so Ig1 is nothing but moment of inertia of this part 1 about its own centroidal axis. So this is a rectangle, so we can write moment of inertia about its own centroidal axis formula as BD cube by 12. So this is part 1, we can write B1 D1 cube by 12 plus a1 hy1 square, and b1 it is nothing but 60, and d1 is 20 by 20 cube by 12, plus a1 we got 1200, and hy1 we have seen previous step, it is 20. So if you write and if you simplify that, we are getting ixx1 as 520000 mm power 4. And next see ixx2 we'll see here. So here ixx2 is ig2 plus a2 hy2 square. So it is ig2 means the moment of inertia of second figure. So the above one is second figure, that is 60 by 20. If you divide here, so here it will be the centroid of second figure. So if you take centroidal axis, own centroidal axis like this from this center point of second figure, so from about that if you find out, it is b2 d2 cube by 12 plus a2 hy2 square, and b2 value is nothing but 20 here, and d2 means second. Suppose if you divide here, so here to here is second part, so depth of second part is nothing but 60. Why? Because total is 80, so 20 minus, so from here to here it is 60, so it is 20 into 60 cube by 12 plus a2 we got 1200, and hy2 we have seen it is 20. So if you write and if you simplify that, we are getting ixx2 as 840000 mm power 4. So ixx1 is nothing but ixx1 plus ixx2. So ixx1 we got 520000, ixx2 840000. So if you add these two, we are getting ixx as 1360000 mm power 4, means 13,60,000 mm power 4. And next let us see iyy. So here if you see moment of inertia about yy central axis, if you see, it is iyy is equals to iyy1 plus iyy2. So iyy1 we can write ig1 plus a1 hx1 square. So let us see here what is the hx1 and hx2. Let us understand here. So hx1 is the distance of centroid of first figure to the centroid of the total figure in the x direction. I'll repeat. So hx1 is the distance of centroid of the first figure to the centroid of total figure in the x direction. So this will become hx1. This is the centroid of first figure, centroid of the total figure. So this is the distance hx1. So from this figure we can write hx1 as, so this up to here it is x1 and this is x bar. So we require this means, so hx1 is x1 minus x bar, x1 minus x bar. X1 we got 30 and x bar we got 20. So if you do that, we are getting hx1 as 10 mm. So in the same way, let us see what is hx2. So hx2 is distance between centroid of the second figure to the centroid of the total figure in x direction. So this gap is nothing but hx2. So from the figure we can write hx2 as x bar minus x2. So x bar minus x2. X bar we got 20 minus x2 we got 10. So hx2 is 10 mm. So here we have calculated hx1, hx2. hx1 is 10 mm and also hx2 also 10 mm. So if you substitute there, so here the formula is for iyy1 is ig1 plus a1 hx1 square. So ig1 is nothing but moment of inertia of this part 1. Suppose if you divide this part 1 about its own centroidal axis. So if about this, if you find out, the formula will become d1 b1 cube by 12 because it is a rectangle plus a1 hx1 square. So d1 is 20 into b1 is 60 cube by 12 plus a1 we got 1200 into hx1 we have seen it is 10 square, and if you simplify that, we are getting iyy1 as 480000 mm power 4. Next if you see iyy2, so the formula will be ig2 plus a2 hx2 square. So ig2 means if you divide here, so this second part, so moment of inertia of this second part about its own centroidal y axis. So you can write it is d2 b2 cube by 12. So d2 will be 60 here from here to here into b2 is 20 cube by 12 plus A2 1200 into Hx2 we have seen it is 10. So if you simplify this, we are getting Iyy2 as 160000 mm power 4. So if you require Iyy, it is Iyy1 plus Iyy2. So Iyy1 we got 480000 in the previous step, plus here it is 160000. So if you add both, we are getting Iyy as 640000. That is nothing but 6,40,000 mm power 4. So this is the way to solve the centroid and moment of inertia for this given L section. For more videos, please subscribe and activate bell symbol. Please like it, share it with your friends, and don't forget to subscribe. Thanks for watching.